Space.
Over the last century, astronomers have discovered many new and mysterious cosmic objects, such as quasars, black holes, gamma-ray bursts, and distant exoplanets. Recent discoveries may be impressive, but in just a few remarkable years in the 1920s, one man single-handedly changed our perception of our place in the universe. His name was Dr. Edwin Powell Hubble. Born in Missouri in 1889, Edwin Powell Hubble developed an early passion for astronomy after receiving his first telescope when he was just 8 years old. In 1917, whilst working on his doctorate, Hubble received a life-changing job offer from George Ellery Hale, founder of the Mount Wilson Observatory in California. But the opportunity came at a bad time. The United States had just entered World War I, and Hubble enlisted in the military. In 1919, Major Hubble returned from the war and immediately travelled to the Mount Wilson Observatory. Still in uniform, he arrived and announced that he was ready to start observing. In 1923, Hubble made his first important discovery using the most advanced technology of the time, the 2.5-metre Hooker telescope. Measuring the distance to pulsating stars, known as Cepheid variables, he discovered that they reside in galaxies outside our own. At the time, the prevailing view was that the universe consisted only of the Milky Way galaxy. Hubble's discovery that our galaxy is just one of many forever changed the way we view our place in the universe. Following this groundbreaking discovery, Hubble began to sort and classify the galaxies he discovered. He arranged them according to their visual appearance, into spirals, ellipticals, lenticulars, and those with an irregular appearance. This became known as the Hubble sequence, and it is still the most popular system for classifying galaxies. Hubble's greatest achievement came in 1929, when he determined that the light we receive from galaxies is redder the further away they are from us. From this, he was able to deduce that the further away a galaxy is, the faster it recedes. Named Hubble's law, the observational discovery of this relationship overturned the conventional view of a static universe and demonstrated that the universe itself was expanding, providing the first observational evidence for the Big Bang theory. Hubble spent the later part of his career campaigning for astronomy to be recognized as an area of physics by the Nobel Prize Committee. The committee finally made astronomical work eligible for the Physics Prize in 1953, but Hubble was never to know, as he had died just a few months earlier. Had the decision come sooner, Hubble may well have lived to receive one. "30 years after Edwin Hubble's death, NASA and the European Space Agency christened their new space telescope after Edwin Hubble. Hubble was the obvious choice when naming a new observatory that would revolutionize the field of astronomy. Edwin Hubble changed our perception of the universe and our place within it, and his spirit of discovery lives on today, through the Hubble Space Telescope.
I find it very
fascinating.
And very good, very well done.
Yes.
It touches, you know.
Yeah.
I was also laughing at some parts, and yeah.
Over its lifetime, Hubble has inspired new thinking about the universe and contributed to more fields within physics and astronomy than we could ever have imagined. But Hubble has also become an icon of discovery, of human achievement, and of culture, and has been the inspiration for artistic work that goes beyond the science. Creations of art and sound. Creations like Tim Otto Roth's Heaven's Carousel, premiered in March 2014 at the 4th Hubble Space Telescope Conference at the Accademia dei Lincei in Rome.
What's the point? You see it glowing, but finally you will see or will hear that there are sounds coming out. So what I'm doing, I'm translating light physics into acoustics. So imagine, that's a simple experiment of the Heaven's Carousel. You hear the stars, the galaxies up on there.
Tim Otto Roth has used sound to interpret the light that Hubble collects when it looks at the stars. This allows us to explore the physics of light with our ears and follows an ancient tradition of linking music to astronomy. 2,500 years ago, the Pythagoreans speculated about a connection between planetary motions and the small numbered ratios that describe musical harmonies. These ratios form the foundation of Western music, and the mathematics of this harmony of the spheres was even used by the renowned astronomer Johannes Kepler. More recently, in the 1800s, Christian Doppler wondered whether the effect that he observed in stars, and which would later bear his name, could be demonstrated with sound. And so it was. First using a brass band on an open railway wagon, and then later by the Heaven's Carousel.
The Doppler effect causes a shift in the observed wavelength of radiation if the source of the radiation and the observer are in motion relative to each other. Now in this simulation we have a light source moving to the right. So to Alice, sitting on the right, the source appears bluer because the wavelengths are compressed. But Bob, on the left, sees redder light because the wavelengths are stretched. The light is blue or redshifted. The same thing happens to sound. As the train with the brass band passed the audience, they would have heard the pitch changing from higher to lower.
Just because I could not afford a whole brass band sitting for days or weeks on a carousel and turning around, well, I just took loudspeakers playing sine waves.
At the center of the Heaven's Carousel, the pitch of the tones is constant, and no Doppler effect is heard. The 36 speakers circle overhead, and neither approach nor recede from your ears. As you move out from the center, the effect becomes steadily stronger. Each new position brings a new perspective, and a different set of pitches can be heard, changing with the changes in direction of the speakers. Wavelengths are stretched as the speakers recede and compressed as they approach. The Doppler shift explains what we see in the local universe when objects are moving away from or towards us. This is one way that astronomers have detected exoplanets orbiting nearby stars. But this effect also has a cosmological cousin. A form of redshift that allowed Hubble's namesake, Edwin Hubble, to discover in the 1920s that the universe is expanding. A discovery that revolutionized our thinking about the cosmos.
Space itself is stretched as the universe expands, and stretched with it are the wavelengths of light from distant galaxies. The more distant a galaxy, the more its light waves are stretched as they travel across the universe, and the redder its light appears. This is the cosmological redshift. Now clearly, the cosmological redshift is somehow connected with distance, but the exact relation between the two depends on how the universe expanded in the past. Astronomers have studied this relationship using faraway exploding stars called supernovae. By comparing their redshifts with Hubble's observations of their actual distances, they discovered that the universe began accelerating round about 6 billion years ago. Now this came as quite a shock, because, after all, the combined gravitational pull of all of the matter in the universe should in fact slow down the expansion of the universe. Why it is instead speeding up is one of the biggest mysteries in contemporary physics.
To the cosmologist, acceleration offers insights into the age and fate of the universe, and perhaps an echo of the prior growth spurt called inflation. But it seems only natural that new knowledge evokes feelings, and feelings are communicated better by art than by science. This incredible dynamic sculpture created by Tim Otto Roth channels some of those feelings about the accelerating universe. Important themes related to the discovery are echoed in the piece: blue shifts and red shifts, isotropy and homogeneity, our inability to see the strings directing the action. The struggle to perceive depth in the universe are just a few, and I am sure you will have and will find many more.
Hubble has shown us the universe, and the heavens carousel has transformed these red and blue shifts into a moving fabric of speakers and sound. The expansion of the universe played out in a concert of sound and light. At times, these sources of sound are telling us through their pitch that they are moving away from us, leaving the same clues that planets around distant stars leave for today's astronomers. And at other times, a high pitch and dazzling ice blue transitions to a deep red and a pitch almost too low to hear, making us feel like an observer of cosmic time, listening as the universe expands and its contents accelerate away from us.
Subscribe now to go deeper into space.